Thank you for joining us today. We'll be getting started in just a couple of minutes. Good day or good evening, depending on where you're located. Thank you very much for joining us for this astronautics webinar. We really appreciate your attendance. Since I know that there's going to be a lot of information presented, let's go ahead and get started. Give me 1 second to share my screen. So first off, I do want to congratulate all of you. It's very competitive with our application process. So it's actually very much a pretty amazing achievement to have been admitted to our MS in Astronautical Engineering program. So again, congratulations on your achievement. And as newly admitted students, welcome to USC in Southern California. So some things, this webinar is here in large part to help you make that really important decision on basically where to go for your graduate school. So we're going to be talking about a number of things, but some things to consider. What are your end career and academic goals when you complete your program? Where do you want to attend school? Do you want to be someplace, warm? Do you prefer snow? All these things are things that you should be considering. Think about the strength of the alumni networks, because networking is a huge part of what you're going to get out of any program. And then if you're interested in research, make sure that there are, plenty of research opportunities and the type of research that you want to do at the schools that you're considering. So LA is basically, I think, a great place to go to school. If you look to your right, you're going to see a lot of what makes Los Angeles such a great place to be. We're a huge urban center, so if you're interested in city life, we have that. You can go surfing, you can go hiking, you can go skiing. You can do all that basically within an hour's drive of USC. On the career front, we are a huge center for tech and tech innovation. Silicon Beach is located here in the Los Angeles area, and it is one of the fastest growing entrepreneurial tech hubs in the world. And in this image here, you can kind of see a lot of what makes us such a tech hub. Um, everyone from Hulu and Google to Facebook, Microsoft, and all of the major tech groups have a presence in Los Angeles. More specifically for astronautics, Los Angeles has been a hub for the aerospace and astronautical engineering center for decades now. In fact, you'll see that SpaceX is here. It's located about 30 minutes south of USC, and JPL, the Jet Propulsion Laboratory, is about 30 minutes north. So speaking of careers, Viterbi does have its own career center. It's the Viterbi Career Gateway, and it's not just a matter of having a career and internship expo. And we do 2 of those a year, and they are very well attended. But more importantly, there's a lot more going on there. There are signature events where you can network with industry professionals. You can do paid internships for class credit. We have advising workshops where you can improve your resume, improve your interviewing skills, and all that kind of thing. There are obviously job and internship toolkits where you can basically explore various online resources. If you're an international student, we have additional career resources specifically aimed at you. And then, of course, we will help you explore the various career options that you have. This slide just kind of gives you even more of what I was just talking about. So Meet SpaceX or the Visa Trojan Talk are examples of some of our signature events. Mock interviews and career and internship boot camp are some of the things that you can attend to improve your abilities. And then Viterbi Trek is kind of cool because rather than having the companies come here to USC, we actually take you out to those companies so you can actually see what those companies look like. And then finally, career outcomes. I mean, obviously, no matter how good our career center is, if it doesn't result in our alums getting jobs, it's not working out. But that's not the case. If you go to any one of our programs and click on the career outcomes tab here at the left, it's going to show you just a snapshot. So it's not a comprehensive list, but a snapshot of companies and job titles that are held by a number of our alums. And these are specific to the program that you're looking at. Excuse me. And then your fellow students. We have an extremely diverse community, as you can see from this image here. And one of the things that's really important with this community is we want you to be able to meet one another and engage on various levels. To that effect, we have an app called Engage SC, which will make sure that you're aware of all the various opportunities that are going on. This image here is of a Holi event that is sponsored by I believe it's our Indian Student Association. The Meta Fireside Chat is just, a chance to meet with an employer. One thing that is really important is a Viterbi Graduate Student Association, where students can actually, you can become involved in student government and help plan events, help other students that may have questions or issues regarding how they're interacting with the department. So I definitely recommend making sure that you either get involved with VGSA or at least know that they are an important tool that's accessible to you. On the entrepreneurial side, we have things like the Viterbi Startup Garage, so you can actually interact with fellow students in entrepreneurial ventures as well. And this is just an image of some of the other events, and just to make sure that you're aware that it's not just within engineering. There are events going on all over campus that you have access to. One thing that we're really proud of is our mentorship program. program. And what that does is when students first come to campus, whether you're a US citizen or an international student, and it can be intimidating coming to a new school. Our mentors are basically there to help you basically become familiar with the campus, answer your questions, and just make that transition to USC as easy and painless as possible. And you'll notice that there have been a number of QR codes and such that will take you to those pages. You don't need to snapshot them now. You will be receiving a PDF of these slides, so you'll have all of that information. Really important, fall 2023 deadline. The most important part is check your letter of admission. It's going to tell you the last day you can submit your statement of intent. Depending on when you were admitted, that date could change. It's generally going to be between April 15th and May 1st. And that will be for both submitting your financial documentation, if you're an international student, and submitting your statement of intent and your commitment deposit. So the statement of intent, this is what tells us that there will be that you are coming to USC. The earlier you submit that, the earlier you'll get access to pre-orientation resources. That's when you'll be able to join the mentorship program. It's also when you'll be able to start connecting with your department through academic webinars, or in some cases, you can even reach out to the advisor if you have a question that you need help with. This is also, once you submit that statement of intent, that's also when you can put yourself in for the housing lottery. So if you want to live in USC-owned housing, that's one of the things that you'll want to do as soon as you submit your statement of intent. So for international students, there is a new system for financial documents. This is really important. It used to be you could submit them in advance, and there used to be a completely different system. So now, even if you've already submitted your financial documentations, you will need to submit them again through this new system called Trojan International. Again, there is a QR code here. You'll get that in your in the PDF that you receive, but just be aware that if you are an international student, you will need to go to the Trojan International page and submit or resubmit your financial documentation. So some next steps. We have a virtual tour of the campus if you're unable to come personally. We have a lot of student organizations, so make sure you take a look at some of these and sort of see what you can get involved with. We have a lot of things for student safety and wellness resources. In fact, one of the things that we are very proud of is that we actually have a wellness officer that is part of the Viterbi School of Engineering. We take basically the wellness, physical and mental, of our students very seriously. And having this wellness officer is actually a major step in making sure that we're able to assist all of our students with whatever their needs are. Going wider to the university as a whole, we do have an International Student Support Services, they're OIS, or Office of International Services, and they're located at ois.usc.edu. We have great students, and we hope that you're going to become one of them. And they love helping and talking with potential students, newly admitted students. A number of them become our graduate student ambassadors. And those ambassadors are there to answer your questions, to chat with you. So do come to the page that's listed here and take advantage of that service. It's a great way to learn more about USC from people that are going to be your peers. And finally, if you have any additional questions, and We will answer all the questions that we're able to, that you submit to us. But in case we don't get to your question, just be aware that you're always welcome to reach out to us. Easiest way is to use this URL here, and we will definitely respond to any questions that you have. So right now, I'd like to introduce you to some of the people that are basically part of this. Luis Ceballos is the graduate advisor for the astronautical engineering program. You will definitely be getting to know him very well. Dr. Mike Gruntman is basically the director of the Master of Science in Astronautical Engineering program, and he is going to be the next presenter. We also have a number of the graduate students that are involved currently in the astronautical engineering program, and some of my colleagues that are here to answer questions that you may have in the Q&A. And speaking of the questions and answers, if you do have a questions, please use the Q&A function rather than the chat function. It makes it much easier for us to find the questions. They don't get buried in the way they do in a chat. So right now, let me. So Mike, if you want to go ahead and take this over, I've made you a co-host, so you are welcome to share your screen.
So I can share, right?
Yes.
Okay. Good morning, everybody. And so we have, I'm a director of master's program and the founder. So we will have a brief overview. Everybody should get a PDF of this presentation. So we will skip a number of pages. We'll concentrate on the important parts, or most important parts. Everything is important. But again, you have the entire presentation. You would look at that. We are in a graduate school. You are graduate students. So you are matures. You have to self-study. So this is the first step. You have to self-study this presentation that you will get as a PDF. So it's again what we'll be talking today about the department, the faculty, coursework, and how the program is structured. And Neil Armstrong is on the left. It's on our campus because he was a student long, long ago before landing on the moon. I will skip the story about USC because you're getting a lot of brochures, a lot of information about the school and the number of alumni and the research and everything else. So it's a great top level information, but again, you will get it. Now, the department. The department is a full-fledged. It offers all set of degrees, bachelor's, master's, bachelor, minor, engineer, PhD, certificate, and the department was formed in 2004. So it's a relatively new department, and this is a unique department in the country because it's a pure space engineering. It's not aerospace where aeronautics and astronautics are combined together. It's a pure space. Now, the reasons, the rationale why we formed this specialized department, unique in the country. If you look at the bottom of the page, let me start my pointer. So if I look at the bottom right of the page, there is a link. You can download a few publications that would explain all that. And the founding of the department was a spectacular success, as you will see from the statistical numbers. It really meets the real needs of space and defense industry. So the department is relatively small in the sense of the full-time faculty, and the full-time faculty is shown on the left. 7 people, actually 6.5, one is emeritus. All our staff members are on the right, shown here. So Luis Ceballos and Priscilla Vasquez are present there. They're our student affairs. And again, department is relatively small in terms of number of full-time faculty, but the strength of the department is part-time faculty and adjuncts that are coming from our large and small space companies and government centers here in Los Angeles who are teaching specialized courses. And this is what put our program aside from many other programs in the country and made it a spectacular success. So the list of our instructors is on the right, and you could see they hail from the places like Jet Propulsion Laboratory from the Aerospace Corporation. This is the Air Force Research Center, industrial companies, Northrop Grumman, Boeing, Microcosm. So it's really, really all the top companies. We have more than 20 adjunct faculty and part-time lecturers, and we faculty, full-time faculty, and now adjunct faculty, we do what real scientists and engineers, practicing active scientists and engineers do. We do research, we do teaching, and we also publish all kinds of books. So you can see the books by faculty and instructors are here. So department focuses on several areas. It's in astronautics, space environment, space science, space instrumentation, propulsion. Members of the department served and are serving on a number of missions, space missions, and the NASA missions, the Air Force, and the cooperation with industry and other government agencies. We also have an important student projects. They are listed at the bottom of this page: Rocket Propulsion Lab, Liquid Propulsion Lab, Lunar Lander, and others. So Liquid Propulsion Lab is a hub for master's students. A very large fraction of our master students participate in the Liquid Propulsion Lab, designing and building liquid rocket engines. So this slide just gives a little bit of statistics. Perhaps the most important is the figure on the right at the bottom, the number of the Master of Science degrees awarded. We are one of the largest programs in the country, and we continue to grow. And it's a highly competitive environment. And this is the reason that I said that our statistical data show that we meet the real need of space industry and aerospace industry. And the reason is that we are growing in the number of the degrees and attracting more and more students. So there is a real need in the industry and government centers for pure space engineering program. We are accounting for approximately 3 and 3.5% of the Master of Science graduates in the broader aerospace field, which combines aeronautics, astronautics, and aerospace. Because our classes are also on the distance education network, and half of our students are on campus, half of our students are online. So our online students coming from all over the United States. In any top right is the map, and if in a state there is some space industry or government space centers, we have students from, or we had students from those states that are coming to our program and getting master's degree. We also have students that are stationed abroad, particularly military. Now, one of the important things about that, our program designed for students with Bachelor of Science degrees in science and engineering who work in the space, defense, aerospace field, or who want to work there. And what is important in order to get to our master's program, you don't have to have a degree in aerospace engineering, bachelor's degree in aerospace engineering. Any science and engineering degree would do it. We will take you from there. You will get in our boot camp. We have one of the required classes that serves as a boot camp, brings students from other majors and introduces them to all things space related. And this is something that is very important for the space industry, because space industry and government, they hire engineers of all possible specialties, chemical, electrical, mechanical, aerospace, and the physicists, mathematicians, astronomers, and they work very well, but they have difficulties growing professionally because they cannot get in a traditional aerospace programs, Master of Science aerospace programs, because they require aerospace degrees in on the bachelor's level, and it will take students from all backgrounds. So as I said, our full-time students, about 50% of degrees account for. Our online students who work full-time and study part-time. Also another half, we have active duty military serving at different installations across the world. And our background of our students, as I mentioned, astronautical engineering, mechanical, electrical, aerospace, all flavors of engineering, physics and astronomy, mathematics, and others. Now, this slide just gives you, and again, you don't need to make notes. You will have this PDF. You will be able to just track the needed information. This slide provides you two very important links. First of all, on the left, right, newsletter URL. This is a permanent URL. Every 6 months, the newsletter is updated, and it carries information about the department, staff members, whom to contact, and also about our classes, in particular our long-term schedule of our classes. Some of our classes offered every semester. Some of our classes offered once a year, and the highly specialized courses are sometimes offered every 2 years. So for your planning, it's very important if you already know the areas of your interest, you may be interested in a certain coursework. So then you use this schedule. So this schedule is part of the newsletter, and there's also a separate link to schedule only. So these two links are very important. Just get there, pull it out, and see what's happening in the program. In order to get a degree, you need to complete 9 courses. All courses are 3 units. And we have 4 required courses: spacecraft systems design. This is basically overview of space systems. It's our boot camp. Then there's a course in space environment and spacecraft interactions, spacecraft propulsion, and orbital mechanics. Then you need to choose 3 core elective courses from our list of astronautics core electives, and then 2 technical elective courses that can be taken. Any science and engineering course, graduate course, can be taken from other department if you want. Most of our students choose these 2 technical electives from the list of our core electives, because our core electives are really the reason why many students join the program, enroll in our program, because this coursework attracts potential our master degree graduates. However, if you need to take a course in electrical engineering, mechanical vibrations, or integrated circuits design, or communications, computers, you are welcome to do it. So 2 technical electives can be taken outside of the department. Master of Science thesis is optional. Very few students take it, a few students every year, so it's very few. And the reason is that the amount of work that goes to write a thesis, to do research, write thesis, is much, much larger than the credit that you could get, the work that is needed to get similar credit in terms of units by simply taking courses. And again, many students enroll in the program because of the courses that they can take. We have a very wide choice of courses. So it's, again, very few students do Master of Science thesis, but majority don't. And this is the reason why the program became so prominent, because we're relying on our practicing scientists and engineers working in the leading space companies and government centers. And Los Angeles, where we are located, is still a leader in the world in space. So we have a tremendous scientific and engineering talent, and the courses that we offer today are listed here. They're color-coded in different areas. There are courses in basically in systems, various systems, low-cost space missions, entry landing, spacecraft systems. There's a courses in orbital mechanics and spacecraft dynamics, cluster of courses. There are courses in propulsion, liquid, rocket, advanced space launch vehicles. There are a cluster of courses on structures, dynamics, and materials. There are a cluster of courses on various subsystems on the spacecraft, like thermal control, power systems, remote sensing, sensors, cryogenic, and ground communications, hands-on course to work or to communicate with satellites. There is also an area of growth focused on safety of space systems and operations. Human space flight is a cluster of courses. This is a unique cluster because we recently, a few years ago, and a former astronaut, NASA astronaut, joined the department, and he is developing this cluster of courses, already just very popular, 3 courses that we have. And these are some advanced courses for like PhD type oriented students in plasma dynamics and computational plasma dynamics. So in order to get admitted, you need to have a Bachelor of Science degree in engineering or science. You don't have to have an aerospace engineering degree, any engineering and science. You have to have a GPA 3.0 or higher, a GRE exam. I'm not sure whether this was reinstated after the COVID, but we will have it when it's reinstated, and 2 letters of recommendation. So about the deadlines, please talk to our student affairs about that, Luis and Priscilla. And typical questions were, how much time does it take to complete the program? For full-time students, they usually take 3 courses per semester. And so it's a 3 semesters are needed, 1.5 years. Sometimes our students pursue internships in the Los Angeles area, and we have Jet Propulsion Laboratory, the Aerospace Corporation. SpaceX takes a huge number of our students as interns. So if students get hooked up and start working, and then they reduce course load, so they may take a little bit longer to get master's degree because of that. Part-time students studying online and working full-time, they usually take 1 or sometimes 2 courses per semester, so it takes, say, 4 years for them. Course sequence. Do you have to follow any course sequence? And the answer is no, it's entirely up to you, except some courses require prerequisites. For example, if you want to take a course in solid rocket propulsion, you have to have a course in propulsion and an introductory course first. So it's orbital mechanics 2 can be taken if you have orbital mechanics 1. So it's in some cases prereqs are needed. Otherwise, course sequence, whether you take required courses first or electives first, it's entirely up to you. However, it is advisable to start with the required courses because they really provide the foundation for everything. Now, sometimes students had similar courses elsewhere before joining the program. Then we waive the required courses. There's no need to repeat coursework at all. Technical electives from other departments? Yes, absolutely yes. And some departments in the universities don't allow it. We do allow, so you can take it. And what is the difference between astronautical and aerospace engineering? I refer you to a publication to that. It's a long story, but basically, historically, traditional aerospace departments treat space engineering as a second-rate citizens. It's primarily still aeronautically focused programs. So this was the reason and rationale that we were founded. And because our enrollment grows in the highly competitive environment, this is an indication that we provide something of real value for space industry and government centers. And finally, some contact information. So Luis Sabayos here, our director of the student services. You can always reach me for any academic questions about the program. We also have our department senior administrator, Del Quasson, who is also very knowledgeable about many aspects of the program. So there are frequently asked questions, how to get approvals of this course or that course. So you can just look here, and there's a link to, again, a publication about the program where a lot of rationale and structure of the program and the concept is being described. And we had some illustrious alumni in the past, so you may recognize some guy on the left. All right, this is all. Should I stop sharing?
You can stop sharing, Mike. Thank you very much for that overview of the program.
And I think I'm on time, right?
You
Yes.
are on time. So for all of our attendees, if you have any questions, now's the time to start adding them to our Q&A section. We did get some questions in advance from as students were registering. So I'm going to throw out a few questions both to you, Mike, and to you, Luis. The first one has to do with research. We have a lot of students that are curious as to what the research opportunities, and in at least one case from one of our online DEN students, whether there are, well, whether they can participate in research, and also whether or not there are any research that they can participate in that might be available as a remote opportunity.
So you want me to take it?
That'd be fine.
Yeah, so primarily the students that are engaged in research are primarily students pursuing PhD degrees. Most of students are mostly focused on a coursework. And this is a short duration program. So if you're full-time students, it's only a year and a half, and the science and technology advanced so far that you need to spend a couple of years to to understand what can be done in terms of research. So it's a very advanced area of science and technology. So most of students concentrate on coursework. However, a huge number of our fraction of our students, they engaged in various student projects. For example, this liquid propulsion lab that I mentioned. Again, these students spend a lot of time. It's a very exciting stuff, and participation in this liquid propulsion lab dramatically improved chances to get better jobs later, because it's work in as I said, teamwork on a real project, and is the firing of the real engines. And the rocket propulsion lab also launches solid propellant rockets. So having said that, research is being conducted by individual faculty. If you're research oriented, you simply knock at the doors of the faculty members and just look for opportunities. Research assistance positions are reserved only for doctoral students. This is the university policy. However, some research work can be done on an hourly basis, then it is compensated. So it's, again, you knock at the doors and talk to the individual faculty, whether you can participate in their research projects, or you can volunteer if this is without any pay. And again, there's one of the issues is that if you volunteer, say 1 hour every 2 weeks, you cannot contribute to an ongoing program, because it's usually, if you start contributing to a program, you are part of a chain, of a sequence. And if you do not deliver something in a week, so other people cannot proceed. So if you can commit 1 hour per 2 weeks, it will never work. But if you can commit significant amount of time, again, either for compensation or as a volunteer, talk to the faculty members. The same for our online student. It's necessary to find a faculty member who can have a task for you to do it. So it's up to you and the faculty to discuss that. And again, as I mentioned, liquid propulsion lab is a lot of students are engaged. Also, we have a space engineering research center. under Professor Barnhart, who is mentioned in this list of faculty, full-time faculty, where a number of our master students are engaged as well on the hourly basis. They're involved in the lunar lander and other projects and the building, participating in the CubeSat developments. We have a few CubeSats already flying in orbits and more in the pipe.
Great, thank you, Mike. Just to add to that, all of you should be aware that all of our labs do tend to be interdisciplinary in nature. So, for example, if you are interested predominantly in robotics and you just want to get involved in robotics, and it doesn't absolutely have to be space oriented, you do have the ability to reach out to labs that are part of other departments as well for research opportunities, something just to be aware of. Luis, this one is for you. We have a few students that are asking, what is the standard course load for an astronautics student?
Sure. Yeah, so technically the course load for full-time students would usually be one class per semester. They're usually working a traditional 8 to 5, work schedule, and then take one class per semester. As you proceed on the program, you can weigh on your workload with personal obligations and obviously with work, and then you can see if you can add a second class. The course content and difficulty is all the same. They're all 500 level coursework, but obviously it just depends on your exposure to different areas. So it kind of mentions to what Dr. Gutman said, selecting your concentration and kind of going based on those offerings.
Ray, I want to add, my advice is always, as Luis said, to start, if you're an online student working full-time, start with one course only, and then see whether you can accommodate the second course. We had a number of cases when very good students take too much coursework, and because they're very good, they're overloaded in their day jobs. And there's a major issues coming with grades. So start with one course. It's only one semester, don't rush, the world won't change, and then add the second one, if you can.
And just to add, if you plan to be full-time student and not working, usually our in-person students are full-time and they take about a full-time course load, which is 3 classes. Our courses are 3 units. So to be a full-time student as a grad student, you need to have more than 8 units. So usually those 3 classes can get you that full-time status. And joining a lab like how Dr. Gutman mentioned, liquid propulsion lab, you'll have a lot of work to you kind of focus on and, obviously go into in that semester that you take that amount of courses.
Great, perfect. I'm not sure which of you is best suited to answer this one. We had a few questions from students that are coming from non-aero astronautics backgrounds, which I know works great for the program, but they were just wondering, are there any prerequisites that they should be thinking about as part of the program?
The answer is no. Specifically, the program is designed for students with all kinds of backgrounds, engineering and science backgrounds, exactly reflecting what is happening in the space enterprise that employs Bachelor of Science engineers from all possible flavors, chemical, electrical system, just you name it. So it's again, you just come to us. It's better to start with the spacecraft systems design course. It's an overview course. I teach it actually. It's a very popular course. It's more than 2,000 students last 20 years. Took it, graduate students. This is like a boot camp, where you get exposure to all kinds of areas, and you will be, it also will help you to make selection of the core elective and technical elective courses, because it will help you to better understand which areas present most of interest for you to study, because space technology is extremely diverse.
Great, thank you, Mike. We did have one question. I'm just going to answer it real quickly. Someone was asking about a 4-year plan for students that are working at the same time. As Mike said, start with one course. You may be able to go up to 2 depending on the courses and such. Just be aware that that you are expected to complete the program within 5 years. Just be aware of that. We did have a question regarding some students were wondering, are there summer classes offered in astronautics?
Very few. Very few. Today we offer 1 or 2 classes. We are looking to increase it, but the issue is that very few students are on campus. Full-time students are on campus, very few. And again, it's in general across the school, not that many classes, but still there are a couple. We have one required class offered there, Orbital Mechanics 1, for example, and also on the spacecraft control or liquid propulsion, so occasionally some other classes.
Okay.
That's why you need to look at the newsletter website and pull out long-term schedule. It specifically addresses these questions. You'll get better feeling for the scheduling.
And just to add, summer semester is not required. You just need to be enrolled in a fall or spring term continuously. So summer semester is not required. It is optional if there are a few offerings, and that can help you progress towards your requirements.
Perfect. So that covers basically all of the questions that we have so far. So Luis, I'm going to turn it over to you to introduce your graduate student panel and to basically, there may be some, so for all of the attendees, if you have questions for our panelists, now is a great time to start putting those into the Q&A. And Luis, I'm going to let you take it over.
Thank you so much, Ray. There was one last question that I don't know if was answered. There is a question: have department scholarships been awarded, or is there a notification coming? So just for information to all, the department does not offer funding or scholarships to graduate students. The School of Engineering, Viterbi, they have a few scholarships available on their website for like DEN students, for example, or some other scholarships from the university themselves, which you can also review on the USC web pages through the scholarship links and stuff like that. But just FYI, our department does not provide funding of any sort to graduate students. We only provide funding to our admitted doctorate students.
Thank you for that clarification, Luis. For anyone that is actually looking, if you're an on-campus student, the scholarships are handled by our department. If you submitted your application by the application deadline, you will automatically be considered for scholarships. We are in the process of making those decisions now. If you are a DEN student, they do have their own scholarship. Please go to our scholarships pages, look at that scholarship. There are specific requirements for that. I believe they actually do have an application that you will need to fill out.
Thank you so much, Ray. So now we'll get started on our next step in the presentation. We will have a student panel with our current master's students in the astronautical engineering program here. We have a few students that will introduce themselves. This will be a time where we'll do a Q&A format, and hopefully we provide some helpful information for you all to know the insights and intricacies of the program. Also, if you have some other separate questions, feel free to add them in the Q&A widget here on the Zoom channel, and we'll go ahead and get started. So to begin, we just would want to know, just some info about yourself, your name, major, hometown, and why did you choose USC? So Akshita, Juan, and Xavier are here to join us. No particular order, feel free to unmute yourself and we'll go ahead and get started. So your name, major, hometown, and why you chose USC.
Okay, I can go first. Hello, everyone. First of all, congratulations on your admit to the astronautical department. It's a great department to be in. My name is Akshita Swaminathan. I am doing my master's in astronautical engineering. This is my final semester. I am from Mumbai, India. And the reason why I chose USC is for the very reasons that have been mentioned until now. It's a very unique program, not offered in a lot of universities in the United States or the world. When I applied to a lot of universities, this was one of the prime options for me because it's in the aerospace hub. It's a great university, and we have the department has a great set of professors, and that's why I chose this university.
Cool. Hi, everybody. My name is Juan Micho Gonzalez. I'm a second-year master's student finishing off the program in this semester. I'm from Hawaii, and I think that was why I chose USC. I chose USC, like you said, great program, great location in terms of like job opportunities with a lot of aerospace companies being here hubbed in Los Angeles. And lastly, I think one thing that I found very encouraging is how supportive not only the AST department is, but also the Viterbi Engineering School as a whole. I know at USC it could be, and then other schools, depending on what department or what school you're in, it can be very cutthroat. It could be very not very cooperative. But here at Viterbi, I feel that a lot of people here support one another, whether they're in your department or if they're in a completely different department. So I think that's been fantastic.
Good morning, everybody. My name is Xavier. I'm a first-year master's student finishing my second semester, and I'm originally from the UK. I chose to do this course mainly because of the location. I wanted to get out of the UK and try do something different. Obviously, the location here is absolutely beautiful, sun shining all the time, and all these hubs around, as Akshita was saying, it's just a good place to be. And also, one thing I've found here, just like Juan was saying, compared to my last degree, it's a lot more of a collaborative experience among your peers, your lecturers, and there's just a lot to get involved in. I'm a part of LPL, which I'm absolutely loving so far. Really, really interesting, great way to meet new people and kind of challenge yourself. So there's a lot to look forward to.
Thank you all. Those are great suggestions, and it's great to hear why you all chose USC. Now going into the academic side and just kind of having your personal review of the classes you've taken so far. What are classes like? How is the homework? Is it demanding? What are your favorite class to this point, if you don't mind sharing?
Yeah, so I can go first. Keep in mind, this might be biased, but I believe that the master program has been significantly easier than undergrad. That may be because my undergrad was like hardcore and I just went ham constantly, but I felt like while the coursework here has been challenging, it has been completely manageable. I've never felt like, maybe once in a while or a handful of times, I felt like it can be overwhelming, but for the most part, if you kind of stick to the you take 3 classes one term and then 2 classes the rest of the terms, it's very manageable for the most part. And I think one of my favorite classes so far, that coincidentally is also one of the most workload demanding courses, is 577, which is entry and landing space design vehicles. I forget EDL. I forget exactly what the class is, but it's super cool. You basically, it's kind of like 520, but more application based. So you, throughout the entire course, you're basically learning about designing an entry, descent and landing mission onto a planet, whether it be Mars or the moon or etc. So it's super cool class.
Thank you, Juan.
I can go next. I think one of my favorite classes so far has been 524 with Dr. Garrett Reisman. Just hearing all of his stories about him being up on the space station and then on the shuttle and everything is just like, I never thought I'd be like racing to get to a lecture. So I've learned a lot in that. Also, 520, extremely interesting. I just always feel like I'm learning like all the time, and it's a kind of a good feeling to feel like I'm getting a lot out of what I'm putting in. So yeah.
Thank you.
I think my favorite courses were in my first semester. I took spacecraft system design with Dr. Crampman. It was literally the first class I took at USC. And the other course I took was Human Spaceflight with Dr. Kate Riesman, which Xavier said. The specialty of these courses is that, it's very practical, and coming from India, where, we had to do like 7 to 8 courses in one semester. It was, like Juan said, it was fairly less overwhelming than an undergrad degree, but we got to learn a lot because of the practicality in which the courses have been designed. So I really enjoyed these courses.
Thank you all. Just to clarify, Juan's course that he mentioned is Entry and Landing Systems for Planetary Surface Exploration with Dr. Anita Sengupta. And all the 3 courses you all mentioned will be offered this coming fall. So for these incoming students, if you all are interested, please feel free to check out our USC schedule of classes. All 3 classes do not require prereqs, so you all would be able to take it if you come in this fall. So just to go on with our next questions, more about getting involved. I know you all are involved in a lot of organizations and different labs here on campus, which is great. So if you can share a little bit about how have you gotten involved with research or in different labs or internships or jobs if possible, and what are some clubs or organizations that you all recommend?
So I feel like I've been fairly involved during my time here at USC. I've been involved in CERC, which is the Space Engineering Research Center that's found in ISI in Marina Del Rey. Fantastic. I was there for a semester doing research on Project Leapfrog that Gruntman mentioned. Overall great, really great opportunity because it's like very hands-on. You get like really thrown into it and you just start working on it. And I felt like working there helped me succeed in my internship that I did that previous summer in Boulder, to the point where like they were so happy with me that they gave me an offer to continue working throughout the year. So after that summer, this whole year, I've been working remotely with my internship company from Boulder. So I think a lot of the opportunities here at USC will prepare you for the real life. On top of that, I'm also part of Viterbi Graduate Student Association, which is one of the largest student associations here at USC, not even just in Viterbi or the engineering school. And we do a lot of planning events for students because as graduate students, we don't really get a lot of time to socialize. So we make those opportunities to socialize, to meet other graduate students, not only in ASTE, but also in other departments like the biomedical or the electrical engineering. So yeah.
Thank you so much, Juan.
I can go next. I was I've been a part of VGSA, which is the Viterbi Graduate Student Association, from my first semester. Juan and I were in fact the department senators, and now we have explored more positions, and now I am the Women in Engineering ambassador at VGSA, and I'm also a part of Women in Engineering, where I'm the assistant director for outreach. So it's a great opportunity to get outside your academics and do a lot of other work. I believe, at least for me, it's important to do other things apart from academics, and being a part of these organizations really helped. Apart from that, I was also working at CERC. I am working at CERC right now. I am working on a project for sensor fusion. So it's been really great. It's a very new project, and we are in the process of creating a new remote sensing lab, which is very exciting. We get to learn a lot of skills. Like, I am not very experienced in electrical. I have an aerospace background, but because I am working on this project, I am getting to work with PCBs, designing them on new software tools, which is really exciting because this is what I wanted. And I would really encourage all students to see what you're interested in and accordingly choose the research opportunity that you would like to do.
Akshita, we noticed that we are on the same place. You're also on the moon.
Yes,
No,
I was just going to come and meet you.
yeah, we should do it.
Yes.
Xavier.
Yes. So I took the first semester here to kind of just find my feet and settle in. But I've recently joined LPL, and so far I'm basically just learning the ropes. They offer loads of crash courses for feed systems, for data acquisitions and control, for the whole engine system and stuff like that. So right now I'm in my period of just learning all the kind of steps that will lead me to kind of find which area within LPL that I'm interested in, and then I can work from there. I recently decided that I want to go into a more systems related like experience. So I'm going to try and take some projects from start to finish and see how it goes. But the great thing about LPL is I didn't manage to get an internship this summer, but the LPL lab runs throughout the summer. So I pretty much got my time sorted there. And yeah,
And
there's a lot of
LPL is the liquid propulsion lab that we talked
Sorry,
before.
yeah, I should have said that. But yes, no, there's exciting stuff. We've got some hot fires coming up soon. We've got the $1 per foot challenge where we build a rocket, send it up, and for every foot it goes up, we get $1. So hopefully we can send it pretty high.
Sounds great. Also, Xavier is one of our student ambassadors. So if you ever need some guidance into your student ambassador platform, you can also chat right there as well. As you all hear, all of our 3 panelists are really involved. They all have great experience. Xavier's recently admitted last semester, and then obviously Akshita and Juan are on the verge of graduating this semester. So you get to see a little bit of both worlds. With time coming down to an end, we just want to ask the last question and just kind of give some advice for our future incoming students. How was, your housing LA life situation, and what is one advice that you would give to these future students incoming to the program?
I stayed off campus for the 2 years. What helped me most looking for housing was Facebook groups, because I wanted to, stay off campus and explore as much as I can. So that really helped. I'm still close to campus. I'm almost like a 7-minute walk to campus. There are a lot of housing options that are there, and it's very easy to get housing. Except for USC housing, which I've heard is kind of competitive, but yeah, you can always try.
Thank you, Akshita.
Yeah, so I live off campus, but farther than Akshita, I live 20 minutes off, so I drive. And I think personally, if you have the opportunity to live off campus, you can find cheaper housing. That way than some of my friends have near USC campus. Sure, it's like a little bit like you're away from everybody and you would have to drive, but I think it's kind of worth it for at least the price and like the flexibility. And also it's nice to kind of have like all right, like I'm in school and like this is like when I'm in school and this is like when I'm away from school, and have that kind of separation of life, I think. But I also utilize a lot of what Akita did, the Facebook groups page to find housing, and I thought it was pretty straightforward for the most part.
So I have a pretty unique living situation. I also live off campus, but I'm house sitting for some family friends, so I got it pretty easy. Probably not the best person to talk to about housing, but I know that living off campus definitely gives you that kind of time away from like. So I suppose if you're a master's student, it's whatever you prefer. But yeah, as the other two have said, it shouldn't be too hard to find somewhere to live.
Thank you so much, all. There is a question in the Q&A chat. Who do you talk to if you want to join one of the teams? So I disseminate the details based on the lab's openings. They do interviews and applications for the liquid propulsion lab team, and similar for our rocket propulsion lab team. For CERC, which is our Science Engineering Research Center, if you want to get involved with that, please reach out to Professor David Barnhart. He's the lead there at the CERC in the ISC facility, so you can always touch base with him. He has several projects in the Science Engineering Research Center. Some of the panelists might have not provided their advice, but as they all mentioned, right, they're all really involved. Some of the best tips that I can provide is connecting with me. I'm your academic advisor throughout the duration of the program. Me and Dr. Gruntman work closely together, so if you ever have any requests or any questions, we'll definitely help you and support you along the way. Touch base with your TAs, who are the persons that will be there in the class, and obviously your professors. We're a smaller department than usual, so we all have an open door policy and can definitely connect with any of you. If you can't get a hold of me, you can obviously try to reach Dr. Gruntman or some of our other staff members, as mentioned, Ms. Del Quason and Ms. Priscilla Vasquez. But as of now, that would conclude our presentation. I do see a few more questions. There is a
Luis, I'll answer this one that just popped up. A recording of the webinar is going to be available to the public. It may take us a little bit of time to get it up because we have to convert it to a public format, but yes, it definitely will be available, as will a PDF of the slides that Professor Gruntman and our team presented. One thing I did want to mention about housing is if you go to housing.usc.edu, especially for those that are completely unfamiliar with Los Angeles, we have a you'll see a map of the campus housing. There's a pink outline, and we do recommend for your first semester, as I said, if you are very unfamiliar with LA, to live within that, because there are additional services and things there, so you can be assured that the housing there is definitely in an area that's basically safe for our students. Other than that, thank you so much for joining us, and many thanks to Luis, Mike, and our student panelists and other advisors. And thank you for joining us, and fight on.